Good morning and welcome to Science and Technology. Today is the 27th day of March 2013. It's amazing how March has really marched on, but I just hope that your answers have been received. Otherwise, you haven't been asking the right questions. And as we unfold what's up our sleeve, we'll remind you, we'll bring you sports, we'll bring you news as we join the newsroom. And oh, Jonathan, I've forgotten that you're here. Good morning.
You always get carried away in giving.
How do you know? How do you know that I've gotten carried away?
For one thing, I think you're in the spirit of Easter.
Oh,
I don't know whether you're celebrating.
It's actually my favorite holiday or my favorite festivity.
Yeah, last year I heard you mention Christmas, and this one too.
It's true. It was Christmas. I changed it to Easter.
anyways, we're talking about science and technology this week. Today, and of course, we have we'll be talking about converting waste, our bola, into energy. We're going to look at how it can be an alternative source of energy for the whole country.
I think you hinted on that in your last interview when you were talking about something related to energy and all
nuclear
that,
energy,
and other alternative way we could we can find energy.
We have more coming up too.
I will actually be talking about biotechnology. A way of boosting our food production and hoping that we wouldn't be starving. So we'll see how the budding and grafting and the other ways of doing. Food. Okay, you are not eating the cooked food yet. You're only talking about how we can generate more or how we can produce more food to feed us. Right. So obviously we're bringing you some terminologies, but we'll definitely break it down for you to know how beneficial it will be for our well-being. As Jesus tarries, we must take care of everything else he's giving us. So that's what we'll be talking about in terms of science and technology. We have all the guests in the house to tell us what's happening around town and how Easter is going to be like. So if you're ready, as we are ready, before we hand you over to the news and then the gas segment comes up, this is what it's going to be. There's going to be a feature or something that we've put together as to how we can transform or generate waste into energy. And Jonathan will be doing that interview, but we will be bringing you something to see before it all happens. But before then?
That's right, that's right. Before then, let's look at our tidbits on science.
Satisfied customers and a clean environment are our aims. That's why we have developed a number of waste recycling and disposal models, such as the MBT plant in Stralsund. Since the 1st of June 2005, only stabilized waste with a low reactivity is allowed to be disposed of in landfills. Clever solutions had to be found. That's why we developed this MBT plant. Overall, an ecologically and economically sound concept. This plant combines the mechanical and biological treatment of household, commercial and bio-waste, and also reduces the formation of harmful greenhouse gas emissions from landfills. After delivery, the waste is cut into small pieces and then separated into two fractions. Waste of high calorific content is turned into refuse-derived fuel, while the organic fraction is treated biologically in an intensive rotting process. Fast, reliable and on time. Every day our employees collect a wide range of waste from our customers located all over Germany. All this with the support of a modern fleet. We return valuable resources contained in waste back to the material life cycle. The household packaging waste collected in the yellow bags end up at our recycling park. Content is mechanically sorted to produce different material fractions that become valuable secondary raw materials. The residual part is then treated in our plastic agglomeration plant, producing annually 35,000 tons of agglomerate in 3 different pellet sizes. The agglomerate is used as a secondary raw material as well as a substitute for raw oil in the steel production process, thus saving primary resources and conserving the environment. In order to recycle hazardous waste, such as contaminated metal and plastic packaging, in an ecologically sensible way, we developed the cryogenic separation plant. In the rotating drum, liquid nitrogen cools down the containers and composite materials to minus 120 degrees Celsius. Residues such as paint shrink and flake off. This results in clean, sought-after metal and plastic materials, which are then returned to the processing industry. This CP treatment plant removes hazardous substances from liquid industrial waste, which arrives from all over Germany. This liquid waste is contaminated with, for example, oil and heavy metals that are removed by the chemical-physical process. Up to 75 cubic meters are treated every day by this plant. The result is wastewater free of hazardous substances that can be released into the sewer, which is guaranteed by the continual monitoring by our laboratories. We think that waste management is about more than just simple disposal in landfills. In 1970, the vast majority of waste ended up in landfill sites, causing damage to the environment. Here, harmful greenhouse gases like carbon dioxide and methane were created and released into the atmosphere. Recycling included only glass and paper. The waste incinerators also released harmful emissions into the environment. Today, incinerators are equipped with modern filters, which results in cleaner air. In addition, heat and energy are produced. Waste is increasingly used as refuse-derived fuel. This conserves our natural resources. Plastic, metal, glass and bio-waste are recycled in an effective way. For us, the future of waste treatment lies in recycling, and that's not only in Germany. We use processes that remove valuable resources from waste. Energy and secondary raw materials are gained and natural resources are conserved. Our services are also available in remote areas, such as on the island Hiddensee, where we are responsible for the waste collection. The protection of the climate and nature is close to our heart, so that the Earth, with its valuable resources, will still be there for future generations.
Well, of course, you saw that over there. Unfortunately, we don't have that technology in Ghana, but it is soon to happen. And of course, Elvis Owusu-Adansi is here to tell us how it is going to happen. Converting waste into energy. All the boiler you have in your house. Do you know it can actually generate electricity for you? It can put an end to all this doom-so. Somebody calls it doom. Almost like I know doom double. Well, of course, Elvis Owusu-Adansi here holds a master's degree in process engineering and renewable energy technology from one of the top universities in Germany. He also speaks and writes English and German fluently, right?
Yep.
And he is also, is it there?
The MD of Nehlsen.
Managing Director of Nehlsen Ghana Limited, a subsidiary of
Nehlsen AG.
You saw the feature, as you saw in the feature there, there's a company in Germany that is actually helping to convert waste into energy. And he is the managing director of the Ghana branch here. He's going to tell us more about how to transform waste into energy. Well, let's go straight to business. Now, welcome to our studios, Elvis.
Thank you.
I like your tie.
Thank you very much.
I like your shirt. So, guten Morgen, as I say.
Morgen, und wie geht's dir?
Wie geht's? Gut.
Sehr gut. Geht's dir gut?
Oui.
Mir geht's auch gut.
Oui.
Yeah.
French. All right. Now, when we talk about waste to energy, give us the details. What are we talking about here?
Okay. Before then, let me say thank you very much to the Almighty God for making this a possibility, and also to the management and crew of GTV for giving me this platform to bring out this solution that will help us come out of, as you said, the so dundum.
That's right.
Issue. In fact, before I came here, I even had to sleep in the dark.
My God.
And I'm hoping this will come to
now,
an
I
end.
wonder why you should come all the way from Germany to come and face this problem.
Because I have the nation at heart. And you know what? I was beaten for not ironing my school uniform some years back in the GSS.
Okay.
Because the Doom So at that time was Doom So.
That's
now it has graduated
it started way back.
Perfectly. So since then, I had it in mind that one day, should the Lord help me grow and then give me the knowledge to study, I'll come up with solutions to this problem, this energy problem. And that motivated me to study process engineering and renewable energy technology.
Oh, okay. Okay. Now, how do you reconcile the two? Waste, boiler, and energy generation.
Okay.
How do you reconcile the two?
When we say waste to energy in simple terms, it's a process of generating energy in the form of electricity and heat from waste, either directly combusting the material or producing a combustible fuel commodity, such as biogas, methane, ethanol, biodiesel, RDF, and agglomerate.
Okay.
And then combusting these materials, you generate your energy in the form of heat and electricity.
Now, technically, in the layman's point of view, okay, when we talk about combustion right now, then you're talking about producing some heat, right?
Sure.
So burning the waste?
Perfect. But burning the waste in an enclosed chamber, not as we openly burn the waste as we do here. So this brings us to the forms of waste to energy processes that we have that is currently in use in the developed countries, especially Germany. Okay. You know that Germans started this waste to energy thing, waste collection in the early 80s. People thought, Germans at it again, but now everybody is moving into renewable energy. Waste to energy is of three basic forms, either incineration, or fermentation, and esterification.
Now, you know what? You have to break all these definitions down.
Incineration talks about, as we said, burning. We burn the waste, and then the heat energy is extracted and used. So you either burn the waste directly, or you develop burnables from the waste that we call RDF, refuse-derived fuel, or biomass, that is materials from the farm. Like in the Western world, maize is grown in large quantities, harvested, and it goes into incinerators. Or sometimes sugarcane is produced in large quantities. The juice is extracted to produce ethanol, and then the aftermath is also incinerated. So the waste comes.
So I'll be very grateful if our cameras can capture what is over here.
So with incineration, it's as simple as this. The waste comes into a storage area, what we normally call a bunker. And it is fed into the combustion chamber or the burning area in simple terms, where it is burnt. And then primary air is blown from the atmosphere into the incineration chamber to carry the heat from the burning chamber or the incineration chamber into the economizers, where the heat energy is converted to steam through the heat exchangers. Water comes into the heat exchanger, and then the energy from the heat is converted to steam. The steam will then go and turn a turbine to produce electricity. Then the steam comes back, it is condensed, it comes back to the economizer, and it's like a cycle. Perfect. So that you put in water, it turns into steam, it generates electricity, the steam comes out.
Comes back again.
Then the flue gas is treated by adding some chemicals so that the NOx and the SOx and the heavy metals in the flue gas is taken out before it is discharged into the atmosphere. So the air that comes out is very clean.
Wow.
That is with the incineration.
Okay.
Then the next aspect is the fermentation process. Or let me say the rotting process, or the digestion process. It is of two forms, dry fermentation and wet fermentation. Okay. With the dry fermentation, we're talking about organic materials that have water content of up to 35%. So like our food waste. In the market, we have our yam, plantain, tomato, etc., etc. They rot. And at the end of the day, they find themselves in the waste bins and then to the refuse dump. Yeah. These materials are collected from our technology into what we call digestion chambers, simply made. And it will interest you that this design is one of my research works.
Oh, okay. Okay. Now you discovered it.
I designed the whole system.
You designed the whole system. Wow. Yeah. Wow. So this is all a machine.
Yeah.
Wow.
So it goes into the digestion chamber and then it is closed, airtight, over a retention period ranging from 25 to 35 days. Okay. But the optimum is 28 days.
28 days.
So as it stays in the fermentation chamber, it rottens and then biogas is produced. Yeah. So the gas is collected and then stored in a gas storage, from where it goes to a combined heat and power plant to produce electricity.
Now, the gas that comes out of it, does it automatically pass through?
Sure.
Some kind of
there are tubes and outlets here. Because the whole system is closed, the gas has to escape through these small openings here.
So with this type, there's no heat, there's no combustion, there's no kind of burning of anything?
It's a biological process.
Okay. So it's just a natural
rotting process.
Okay.
In an enclosed chamber.
Wow.
That's all.
Wow.
So heat and power are produced simultaneously.
Now, how much waste do you need in that hole?
Okay. It depends.
Before you can generate the amount of power needed to power a whole nation.
Good. It depends on the size of the plant that you're building. For example, when you take the whole of Accra, Accra generates 806,000 tons of waste per year, which is about 2,200 tons. Wow. Municipal solid waste, excluding the industries. 100,000 tons of waste, when you take it through an incineration process, generates 104,000 megawatt hour electricity.
Oh, wow.
And 235,000 megawatt hour heat energy. And after the incineration process, when you incinerate 100,000 tons of waste.
So in other words, we are producing so much waste that can actually power a whole nation.
Sure.
For over a period of years.
So let's assume the average Ghanaian uses 1 megawatt hour per year, the average, because the normal flash screens that we use at home uses around 250 to 270 kilowatt hour per year. So let's take your fridge and then other gadgets.
So the lights consume less.
It consumes less, of course. So the average Ghanaian will use, let me say, 1 megawatt hour per year. So which means 100,000 tons of waste, that is 1/8 of the quantity that is produced in Accra, can take 104,000 homes out of the national grid.
Wow. Wow.
104,000 households out of the national grid.
Wow.
And when you incinerate 100,000 tons of waste, you get 17,000 tons of incinerating ash, which looks like this. Almost sand.
Can I feel it?
So in Germany, this is used as the first coat during construction processes.
Oh, okay.
So it's like the waste is not waste, but it's wealth. After the energy, that is the electricity produced, being used, the heat energy being given to the industries to be used. The ash also goes into construction processes.
What is this used in construction work?
in construction roads, one needs sand, one needs gravels, and this is 100% sand.
Okay.
So if you're generating 17,000 tons of this, and you're constructing, let's say, from Accra to Nungwa, the sand quantity that you'll be using in the construction process will be lessened by 17,000 tons.
Wow. Anyways, let's not divert into
okay.
other areas. There's so much that we can use natural things to produce.
Yes.
There's so much. Let's look at the third process.
And the third process is the wet fermentation, which uses organic materials that are in the liquid form, at least to a minimum of 75% water content, so that it can be pumped.
Okay.
So here we're talking of grinded organic waste, like from the food stuff, from the markets.
Yeah.
Those rotten foods are grinded, mixed with water, and then stored in digesters.
Okay.
And then it goes through the same process as the dry fermentation process.
Fermentation process. Okay.
And one interesting thing, we've been advocating the construction and the use of KVIPs. Perfect. I love the idea so much because it improves sanitation.
Yeah.
But the question is, where does this human excreta go? That is a question. And it will interest you to know that when you digest 1 cubic of human excreta, you'll be generating 20 to 30 cubic meters of biogas.
Oh, that's right.
That is 1 cubic. And 1 cubic meter biogas generates 1.87 kilowatt hour electricity. So let me make an example here. When you pick, let's say, Ashaiman and the surrounding towns, Mataiko, Mishelkam, etc., etc. I've researched and I've seen that between 800 to 1,000 cubic human excreta is generated every day.
Every day, wow.
Which brings it to 360,000 cubic meters. So if you are to pick, let's say, 10,000 cubic meters of this, it can produce 10 million cubic meters biogas, which is 18,700 megawatt hour electricity.
Wow. We're talking about all these things. I mean, human excreta, you know, our waste from our homes,
all the
waste, industrial waste, and all those things can be generated into energy for this country. Now, do we have the technology here? Is it possible? What's the possibility?
It is possible because we're not starting from nowhere. We're starting from somewhere. This technology has been in use when you go to Europe, to be precise, Germany, and to be precise, Nehlsen Ghana.
Yeah.
This technology has been in use for more than 30 years, way back in the 70s. And I've, by the grace of God, worked with this company for a long period of time. And I've personally worked in all these plants and know how it works. And I've been here to assess our waste stream.
Yeah.
And I am 100% sure that that technology can be transferred here to help us. And let me chip in this short point.
Yeah.
We're now having problems of drinking water. No water here, no water there. We need water. Government should come to our aid. It's true, yes. But that problem also can be solved. Because one of our processes in Abu Dhabi has revealed that 4 megawatt hour energy can produce 16 million liters of drinking water from the sea by desalination process, which we do.
Wow.
Which is almost 4 million gallons of drinking water with just 4 megawatt hour electricity. So let's say if we have 100,000 ton capacity plant around the coast, maybe at Kpong or Kolegono or Choko or a place near the sea, we can get rid of our waste, generate electricity, and possibly convert the sea into drinking water. The technology is there. It is being used. And I'm a living witness. So if we are to do the same thing in Ghana, it's just a copy and paste. So I would say it is possible to do that. But of course, we all have to get involved.
Yes. Before the interview, we were talking about the concerted effort. Looking at this from a concerted effort point of view, okay. Now, in your estimation, you've been in Germany for some time.
Yeah.
Now, regulation with waste disposal in this country is a problem. Now, you go to certain places now where waste is not supposed to be, that's where it is. And there are some of these tanks that have been put at vantage points, let's say at markets and all that. These things could be full for so many weeks and months, and nobody says anything about it. They are still there. How do we regulate this?
The question is, it is not being picked, because when it is picked, where does it land?
The dumping site.
The dumping sites are full. So if I'm to pick it now, where do I send it? I think these are some of the limitations that are hindering the waste management companies like myself. And if this technology comes in, because the waste is being worked on and is reducing, it will be picked. And talking about legislation, that's why it is always expedient and important to run such programs together with the community, or to be precise, the assemblies, because they can enact laws that, okay, for now on, the waste is going to point A. So nobody is to send the waste to point B, but point C, so that it will be carted from point C to point A.
In fact, the regulations are there, okay? The legislation is there, but then is the attitude of the people.
It can be changed. It can be changed.
How, in your estimation?
The Germans started from where we are now, and now it is changed.
What is their process? How did they change?
Let me bring a scenario here. If you want to send the African, or you want to let the African man or woman do something, attach some money, and the person will do it.
I mean, how rich are we? How rich are we to always attach money to use money as a bait?
Little incentives will do. There is a way out. Trust me. I've done my research.
Okay.
Yeah.
And what did you discover? What did you come out with?
It is possible. When we see that measures are put in place, the waste that are being collected are ending up at a point where it will be of use to all of us. I am 100% sure that Ghanaians will be ready to embrace it and then do as it is said.
Okay. Okay. I'm beginning to get your points, but then make it more clear to me. Now, how do we always entice people with money?
Good.
Just to dump waste in the appropriate way.
We are now paying for the waste that we generate. Everyone is paying. Because in your home, you have some waste bins.
Yeah.
You put it outside. The waste management companies come they pick it up. At the end of the month, you pay.
Yeah.
So
but
if
nowadays they are not forthcoming. I mean, for so many weeks now, they haven't come around.
They will come. When we rally around this project and the waste is being put into use, they will definitely come. They will definitely come. So let me answer your question. You are paying for the waste. Let me say X Ghana cedi per collection. If you are being asked to segregate your waste into recyclables and then the organic fractions, so like the paper, the plastic, the metals, and all those secondary raw materials goes into one bin, which will be taken free of charge. You won't pay. And then only the organic fraction, which will be taken, will be paid for, which means you've reduced your waste management or waste collection fee by a margin, which you'll be glad to do. If someone is sent to come to your house, pick those recyclables to be treated, to be reused by the industries for a fee, that person will come. That is what I mean by enticement.
Okay.
So that if you add all together into one bin and you are paying, let's say, 10 cedis, you separate and you get about, let's say, 50% of the bin being the recyclables. You will not be paying 10 cedis again, but you'll be paying 5 cedis. So indirectly, we've given you 5 cedis payment from your own pocket.
Okay. Well, now, let's look at how we can actually get this or import these technologies down. Okay. Now, practically, how long will it take to establish such a plant?
Depending on the sizes that we really want to do, it takes a very.
Now we're looking at actually providing energy for the whole nation. Okay, and we need such plants. Okay, how long will it take to establish it?
Very short time. A very, very short time.
How short?
Very short.
Because from the look of things, from what we saw through the feature, now this is a whole industry. It's big.
Yeah, but there are smaller plants. The model starts from 10,000 tons capacity to 20,000 up to 500,000 tons.
Okay.
So if, let's say, we start with smaller plants at smaller areas to take out the salient communities or, let's say, institutions out of the national grid, that is also a breakthrough.
Yeah.
And if industries are encouraged and then helped by the government with low interest and flexible loans to go into waste to energy, they will be taken out of the national grid. So indirectly, we will be solving our energy problem. Let me give you a scenario here. When you come to Staffenhagen, it's a city in the northern part of Germany, in Mecklenburg-Vorpommern. There is this company, Fanny GmbH und Co. KG. They process potato chips and potato powder. It's a company owned by Unilever.
Okay.
We working hand in hand with them. They contracted us and we built a waste-to-energy plant right on their site. We process 100,000 tons of waste every year and generate 104,000 megawatt hour electricity. And then 235,000 megawatt hour heat energy in the form of steam. So the steam goes in their production process and then they use the electricity that is produced and the excess is fed into the national grid. So companies like Fanny and all those people have been taken off the national grid.
Okay.
So the little that the nation is able to produce fits everybody.
What do you have there?
What I have here is the last form of waste to energy. That is esterification, converting waste oil into diesel.
Okay.
When you come to Bruggen, we have a plant there. All hotels, food joints, etc., etc., store their waste oils in containers that we go around to pick them. And I tell you, the conversion ratio is almost 1:1. Actually, it is 1.1 waste oil gives you 1 biodiesel. So let's say 1.1 kilogram waste oil will give you 1 kilogram biodiesel.
Oh, wow. Okay.
So it's like we have a lot of hotels, high-rising hotels coming up, very good. Food joints are around the corner, perfect, helping us. But the waste oil, the oil that is used in the frying process, in the cooking process, they end up in our drains. But if they are given containers to be stored in, this waste oil, through esterification process, can be converted to biodiesel, which will be used in our trucks. And it will interest you when you come to Germany. All Nehlsen fleet of cars uses biodiesel.
Oh, okay.
That we produce ourselves in Bruggen, and the rest is sold to the public.
Okay, so you do produce cars too. It's not just into waste management.
No, we don't produce cars, but we produce diesel.
Diesel
to be used
to power your cars.
Our cars.
Okay. Now, when we're talking about looking at this from the industrial point of view, okay, then we can have actually a private company without government support setting up this kind of plant in this country.
It is a yes.
And from the way you're talking, okay, we can have it on a smaller basis.
Sure.
Till it gradually builds up, okay, for the whole country.
Yeah.
And if that is the case, can't we have a company like Nehlsen, okay, coming down here to establish it without government support, establish it, provide that kind of energy to households?
Good. It's a very good question. And let me start answering it this way. Waste to energy, like all the other forms of energy generation, hydro, nuclear, solar, wind, is expensive. Let me say a little bit expensive, but not as nuclear, hydro, and those stuffs. So the risk involved is a bit higher, number one. Number two, the revenue to sustain the project hangs on three things: the input material, that is the waste, the products, that is the electricity, the heat energy, and then the incineration ash that will be produced. And then when you go into composting, that is the dry fermentation, the aftermath, which will turn into compost like this.
Okay, for Greek people.
Perfect. So these are the products that is only going to sustain the project.
All right.
So let's say a private man comes in. By God's grace, he has the money. He sets up the plant, but the waste is not coming. But when the waste comes, it is not paid for. The sustainability goes down.
Now, as a businessman, you should also make all these calculations and feasibility studies before you establish it. You know you need waste to generate. Waste is your product.
But who handles the waste?
Who handles the waste? So you make
the
those
assembly.
Calculations. Okay.
So you cannot do without the assembly, the controllers of the waste. So even if you are a private person, you have the money, you still need to collaborate with the assembly. That is why a PPP project is the most ideal. A public-private partnership is the most ideal, because you need to be in contact with the controllers of the waste, and then controllers of the energy that you're producing.
Okay.
Where does it go? Ghana is not like the advanced countries where you can produce your own energy, then you sell out. It's like Yellow, SVB, that are some of the energy producing companies in Germany. They know the individual households that are using their energy. So you need to collaborate with, let's say, VRA, PURC, ECG in selling the energy. And of course, you need the feed-in tariff, which is still not yet out. So you still need to work hand in hand with the public. That's why a public-private partnership is the best.
Public-private partnership is the best. Okay. So still government comes in whichever way.
Sure.
But not like to provide money or to subsidize anything. Just some collaboration. You need endorsement from the government.
If it is a public-private partnership, then it is contribution from both sides.
Okay. Okay.
Contribution from both sides. Because it takes two to tango. And government cannot do it alone. We need to assist the government because we produced the waste. So if the waste is to be taken care of, we, the populace, must support the government to handle the waste.
Okay, so it is a concerted effort. Thank you very much. Elvis, you've actually enlightened us on how to actually use waste to produce energy for the country. Your final words.
So at this time, I would like to appeal to my listeners, the assemblies, the government, the private companies, to come on board so that we move the nation forward and then also help alleviate this doomso or doomso issue to a minimum as level. And I would like to thank everyone for listening, all friends who have helped in propagating the good news, like my friend Bismarck Osei and the others. Thank you all, and thank you also for inviting me.
Oh, you're welcome. I mean, we need more of such brains to actually help us develop the country. I mean, we can do it. It is very possible. We can do it. And Elvis is showing us the way right now. Thank you very much, Elvis, for joining us. Thank you very much. And we believe we can all do it.
Yes, we can.
We need that concerted effort. Come together, collaborate, and help alleviate ourselves from poverty.
Sure.
All right. We're still talking about converting waste into energy. Let's look at how waste is actually burnt. The combustion of waste. Watch this feature.
Which is located in Stavenhagen, Mecklenburg-Vorpommern. We are the owner of this plant and sell the energy produced to Fanny. This plant is an innovative step towards ecological and economic energy production. Built right next to Fanny, the operation started in August 2007. Refuse-derived fuel is delivered from the districts of Mecklenburg-Vorpommern. This refuse-derived fuel consists mainly of dried and shredded household and bulky waste. We turn this waste into energy. The mechanical gripper supplies the combustion chamber of the plant with refuse-derived fuel around the clock. Here, temperatures rise to more than 850 degrees Celsius. The water from the boiler is passed through a system of pipes. The water is heated by the incineration process. Steam is produced. Steam is delivered to the production process of Fanny via a heat exchanger. A turbine turns some of the steam into electricity in order to meet the plant's own demand. This process is controlled 24 hours a day to ensure that Fanny is supplied with steam and electricity day and night. This cooperation has a clear economic advantage for Fanny. The company will have lower energy costs that they can rely on and is independent from rising gas and electricity prices. That's how we operate in a closed-loop product life cycle. Overall, it is a cleaner solution because around 20% less carbon dioxide is released into the environment. We plan, build and operate biogas plants such as the plant in Zagard on the island of Rügen. Organic materials such as manure, dung and food waste are delivered and then degraded by microorganisms to produce biogas, which is then turned into electricity by the combined heat and power plant. Up to 836 kilowatts of electricity is produced and fed into the national grid, supplying around 10% of the households on Rügen with green electricity. Another product that helps reduce carbon emissions is the renewable energy source biodiesel, which we produce in Grimmen in Mecklenburg-Vorpommern. Made from used plant-derived fats, such as old edible oil, the plant produces 37.5 million litres of biodiesel annually. Regular controls guarantee a product of high quality standards. As a waste management company, we want to play an active role in environmental protection. That's why it is important to us that our fleet uses biodiesel throughout. This also applies to our haulage company, Prolog Transport and Logistic GmbH, which uses specialised vehicles to transport both for us and third parties goods throughout Europe. We look forward to being on the road for you too. We're driving forward into a safer future.